Alright, here is the physics engine I've been working on. Let me just move this off camera real quick. Now, the frames per second of the video looks like it's about 9, so you guys won't get to see this in nearly the resolution or frames per second that it's capable of. I don't know if you can see it, but there's a frames per second counter towards the top there. Now, when I ran this earlier, I was able to maintain above 20 frames per second most of the time. There's some physics for you. OBB, sphere. God, the recording is severely lagging my computer. This runs with up to 100 plus physics objects pretty easy, maintaining usually over 60 frames per second. I guess this is just really laggy, but here's some OBB just in case you wanted to see it. Now, those balls at the very far end, those represent essentially sphere plane locations. I'd show the collision with those, but honestly, it would take me so long to get over there because this camera is designed only to move in small amounts. I can go over there, and both of these will bounce off of the plane. And OBBs will bounce off of each other, in case you were wondering if I can... God damn it. I can't hit the damn thing. But yeah, they'll bounce off of each other just fine. So there's full physics in here. Just for a little bit of fun, let's blast the crap out of this thing and see what happens. I gotta admit, I have Octrees in here, which I call it Hydra Octrees because the engine's the Dragon physics engine. Just because I could, really. I think I've got... Yeah, Octree should be working now, because it starts working at about 100 objects. I could probably make it work with, start working with less, but I'd have to add more iterations to the algorithm. And there you go. Full physics means that you end up with everything everywhere and not interpenetrating nothing. It's beautiful. 60 frames per second, and that's 4 o'clock. Sorry about that. That's my alarm. I get up at 4 a.m. every day I have class. So, this is the physics engine I've built, and I'm actually kind of surprised it's running at 70-something frames per second, considering the recording device is still on. So, that was nice. I've got a Phong pixel-based shader in here, which is why if you move, stuff sort of lights up every now and then. It's pixel-based lighting, which is actually very GPU intensive, but, well, relatively. It's more than vertex-based lighting, which is not important. This is a physics demo, not a graphics demo. These aren't stock DirectX things. The boxes and such I made myself in 3ds Max, and I threw the binary on there because I could. Now, you may want to realize how accurate these boxes and spheres are to their physics counterparts. That's kind of why I made them in 3ds Max, because it turns out the default unit in 3ds Max is whatever unit DirectX uses. So these spheres here are scaled to 10 because their default width or radius is 1. So I scaled them and they are identical. So if I just barely push it, it'll hit it. I just have really crappy accuracy. There we go. And these boxes are at 5 each. So if you... I don't know if I can do this on camera. Let's see. Yep, missed it by that much. I've actually had some pretty close collisions that were like really stupid close, and they didn't detect a collision. By the way, up in the left, triangle count, not triangles. It's contact. bits. That's the number of contacts that this thing has generated. It's a running total, so if I make a contact like this, you'll see the counter go up. There. 4,392 contacts have been generated for this iteration. So, there you go. Bunch of physics stuff. The highest number of objects I've ever had in this thing was at 500. And, well, I'm not going to show you that because I highly doubt that my computer would run the capture thing and 500 physics objects. Occasionally my computer actually pops up with a warning saying that this thing is using up a lot of my CPU, and I'm like, I know, because physics is really CPU intensive, and we're going to have a very graphics heavy game, so I have to run it on the CPU. I guess more optimization might be in order, but for now, this is good enough. The next thing I'll be doing is some, oh, what do you call those things? Forces! Yes, forces. So, in the next demo, I'll have gravity, hopefully, which I'll probably bind to one of these buttons. I'm on a 360 controller, by the way, using X input for this demo thing. See? These guys are pretty freaking close, but, yep, not contacting. See? There's a good example of why I made these myself, because I wanted to know exactly what size they were so that I could scale them properly. The cubes are actually 0.5 in each direction, so 1 is their normal width, so you set their half spaces to 5 and they're 10, which is why they're roughly the same size as the spheres. Now, this is still running. Oh god, this thing is recording in like 5 frames per second, so I feel really bad for you guys watching this. Hopefully it's not terrible. I mean, I am moving this thing really fast, so you guys probably can't see half of the crap I'm talking about. But it works pretty good. By the way, this is running in debug mode. For those of you who know what that means, it means that I can get this thing to probably go a fair amount faster if I ran it in release mode. I just kind of forget how to set up DirectX to run in release at the moment, so you guys are going to have to deal with debug because I have to debug this thing every now and then. Octrees didn't actually take that long. Only took me maybe 5-6 hours. Hardest thing was the rest of the physics engine, but for the most part this runs pretty good, and I like to, you know, sort of play pool with spheres and boxes and stuff. Let's see, okay, 2 minutes till 10, alright, we'll go to the plane, which these spheres just represent the general location. I made them basically by setting their position to their normal times the what do you call that thing? Oh, the distance from the origin. So I have no idea where the heck this is. I just know it's 9,000 units, I guess, from the origin. So here's some physics objects going that way, and boom, they bounce off. Now, if you wanted to know where the plane is, it's somewhere over there. I probably should fix this into a box or something, but, you know, I'm just too damn lazy to do it. So, there you go. Plane is somewhere over there, basically in the center of this. And, the plane is not a half space, so if you shoot the other direction, it will maybe bounce off. No. Okay, so OBBs won't bounce off because they're half space only, but, well, if I can, there it is. Yeah, spheres will bounce off, OBBs will only bounce on one side. So, if you're in a sphere, you're kind of screwed if you get outside the world because you can't get back in. You just can't. OBBs, on the other hand, will go right through it, only in one direction. I want to make that clear. OBBs will bounce off on the correct side of the plane. spheres will not go through, by the way. Just make that clear too. Spheres will bounce off, but if you get to the other side, they'll bounce off the other side too. And we're still running at 60 frames per second with 200 objects. Let's go back here just to see what's up. Oh, this takes forever. Blah, blah, da, 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 da. By the way, I just clicked a few buttons, so there's some physics objects behind us. Somewhere over there. Let's go back to this mess over here, which probably has close to 200 physics objects. I know I made a couple over there. So this is still fine, as you can see. Nothing's really changed. I'm sure some things have been updated since we left, but, you know, for the most part, they're fine. At this point, probably every object here is asleep, and the engine actually doesn't care. If two objects are asleep, it doesn't even bother trying to detect a collision, because in order to detect a collision, one of them has to be awake. If they're both asleep, they're both not moving. Therefore, it's impossible for them to have generated a collision since they're both asleep. Just a little bit of logic there that, you know, can save you several frames per second, I guess. So, just below 60 frames per second, not too bad. OBBs will rotate in any direction. It's a little tricky to get them to rotate in some directions, I'll admit, but they'll change their orientation based on that. I just keep ending up hitting them in the wrong frickin' spot, so there you go. There's the other direction. I don't know if there's any other axes I can get these things to rotate around. In case you are wondering, they are using quaternions for their orientation, so yeah, that was fun. Let's do quaternion stuff, and yeah. They have inertia tensors based on mass, and wow, I did put a lot of objects over there. Their inertial tensors are based on the actual mathematical formulas for calculating inertial tensor, and I am starting to lag here. Okay, but yeah, it's based on their real inertial tensor formulas, which is based on mass. The formulas assume that the center of mass is at the center of the object, but that's what I'm going to assume. If you want to put it somewhere else, good luck. I'm not going to put that in here because these things probably won't be used in any physics simulations, and I'm sure some of this stuff could probably be turned off or something, but for the most part they work pretty well. So yeah, that's the physics engine. I've called it the Dragon Physics Engine, which is what the video is probably going to be called. It's in beta as it doesn't have forces yet, which will be used in conjunction with a friend of mine's AI moving algorithms. So that'll be fun. Yeah, Dragon Physics Engine. Ooh. So much fun. Okay, so that's that. Hope you all have enjoyed, and as always, have a nice day.